Okay, um, now we are doing 10.3 before we get into 10.2. There might be a little bit of information that we're missing that we need from 10.2, but I'll just cover that as we go. So let's just jump into 10.3. And so we're going to focus on chords, and we'll talk a little bit about arcs. Now chords, if we remind ourselves what a chord is from 10.1, a chord is a segment where the endpoints are at two different points on the circle. Okay, and so you can see here that we have a chord, and it's a segment, and you see that we have two different endpoints on the circle. Now, a chord can also be another word for chord. Well, a diameter could also be a chord, but a diameter is a specific type of chord where it's a chord that passes through the center of the circle. Okay. Now, so that's a chord. Um, Now, a chord divides the circle into two arcs. So, an arc of a circle is pretty much like the arc of a circle is pretty much just like a portion of the circle. So this would be considered an arc, or it could be something like this could also be an arc of a circle. So it's just like a portion of the circle. Now, when a chord is specifically a diameter, or any chord actually divides a circle into two different arcs. Now, if it's a diameter chord, then the arcs have a specific name, and we call this right here a semicircle. So if the chord is a diameter and you have a diameter, then the circle will be split into two different arcs, which we call semicircles. So this is a semicircle. And this bottom half is also a semicircle. I don't think you actually need a hyphen in that. Semicircle is just one word. Okay. Now, whenever the chord is not the diameter, the arcs, we have what we call a major arc and a minor arc. Okay, so a major arc obviously is the portion of the circle that's larger versus the smaller portion, which is the minor arc. Okay, so we have major and minor arcs. Now let's get into this theorem, the congruent corresponding chords theorem. So what this says that in the same circle, or in two congruent circles, two minor arcs are congruent if and only if their corresponding if and only if their corresponding chords are congruent. Okay, so let's read that again. So in the same circle, so in this case we're talking about one circle, or it could be in two congruent circles. Two minor arcs, so here's a minor arc right here. So two minor arcs are congruent, so these will be congruent if and only if their corresponding chords, so here's their corresponding chords, so if they are congruent, then then the arcs are also congruent. So that's pretty much all it says. So knowing that, let's go to example 1. So it says in the diagram, circle P and circle Q are congruent. So these two circles are congruent, meaning they have the same measure. it says that FG, so this chord right here, is congruent to JK, which is the chord in circle Q. It also says that measure of arc JK, so this measure right here, is equal to 80 degrees. Now, arc is measured in degrees, so that's something that we actually learn in 10.2 that I'm just going to introduce now. So say that we have a circle, okay, and we have the center of the circle. So let's say that we have a piece of the circle that looks like this. Now, this right here is the arc, but the measure of the arc is the same thing as the measure of the interior angle. So right there, that would be the measure of the arc. They'd be the same. Okay, so pretty much what we're saying here is that this angle right here is 80 degrees, which is the measure of this arc. Okay, so it wants us to find the measure of FJ or FG. Okay, now it follows directly from this congruent corresponding chords theorem that this has to be the same measure, because we know that FG is congruent with JK, and we know that these two circles are congruent. So by the congruent, I'm just going to shorten this, congruent corresponding chords theorem, CCCT, it follows that measure of FG, so the chord FG, is equal to the measure of the chord JK, and we know that the chord JK is equal to 80 degrees. So then this one also has to be equal to 80 degrees. Okay, that's pretty much all it is. So in these exercises right here, these are really, really easy exercises. Okay, so it says find the measure of the chord or arc or the chord. So measure of arc WX. So it wants to know the measure right here of this arc right here. Okay. Now we already know that this measure right here is 42 degrees. So this is 42 degrees. Now these create a these create vertical angles, so this one also has to be 42 degrees. So this means that the measure of this arc is equal to 42 degrees. I'll let you let's see, can I? Okay. I think you guys should be able to finish the rest. Well, YZ right here, so it wants you to find the measure of this line segment right here. But just look over here, this line segment is 36. Now it follows from the corresponding, congruent corresponding chords, that if the chords are congruent, then that means the segment is also congruent. So if this right here is 42 degrees and this right here is 42 degrees, well, that means that these are congruent. So I'll let you piece that together. It wants you to find WZ. Okay, WZ. Well, these are also vertical angles, which means their arcs are going to be the same. So this arc will be the same as this arc. So they'll be congruent, which means these corresponding chords are also congruent. So I'll let you piece that together and that together. Okay, so that should be more than enough information to fill in the rest, and it's pretty easy just by looking at it. So I'll let you guys do that. You can pause the video if you need to, but I'm going to keep moving. Okay, now the perpendicular chord bisector theorem. So this one says, if a diameter of a circle, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Okay, so here you see that we have a diameter, right? Diameter is a chord that cuts through the center. Now, if it's perpendicular to a chord, so like right here, this is another chord, if it's perpendicular, then what that means is that it is bisected, which means that this side and this side are congruent. So it's cut in half. The chord is not the diameter. The chord is cut in half. And that also means that the arc is also cut in half. So that means that this arc length has to be the same measure as this arc length right there. And that's pretty much all it says. And it says that the converse is also true. We should also note that. So the converse is also true. So meaning that right here, so if these arc lengths are congruent, and these segments of the chord are congruent, well then that means that this diameter bisects this chord right there. Okay. So there you go. It basically just the converse says that this is the diameter of the circle if these are all congruent right there. So that's the converse. So we'll use those theorems in the upcoming examples right here. Okay. So example 2. So find HK. So here's this diagram right here. Now you see here that it indicates that it's perpendicular, right? So we know that this is perpendicular, which means that this right here, this diameter in this chord, because it intersects perpendicularly, then we know that it's bisected. So this segment HN has to be congruent to this segment. This arc length has to be congruent to this arc length right here. So HK, we want to find the measure of HK. So that's from here to here. So what is that distance right here? So thing is, we know that NK is 7, and we know that these are congruent. So this HN also has to be 7. So then H to K has to be 7. So that one has to be 7. Or sorry, because they're both 7, they have to be equal to 2 times by 7, which is equal to 14. Okay, sorry, that's what I meant to point out. Okay, now it says that it wants us to find the measure of HK, or the arc HK. So we want to find the measure of this arc right here, H to K. So we know that this arc length is congruent with this arc length. So given that this one is 11x, I know that this arc length 11x is equal to 70 plus x. And now I can solve for x. So I'll subtract x from both sides. So I'll get 10x is equal to 70. Divide by 10 on both sides, and x has to be equal to 7. So that's the measure of x, though. It's not the measure of the arc HK. So we'll plug 7 in here. So if we plug 7 in here, this would be 77 degrees, right? Now we already know that this one also has to be 77 because it's congruent to this. So if we want to find the measure of this entire arc, we have to multiply this by 2. So 77 times by 2, which is equal to 154. So that is the length of the arc HK. So knowing those theorems, those two theorems, the perpendicular chord bisector theorem and its converse, it wants you to solve for the value of x in these figures. Okay. Again, I think this is a pretty straightforward theorem. So you want to find the value of x. Remember, this chord right here has to be congruent with this chord right here because it's bisected, because this is perpendicular. same thing follows here. So knowing that, you should be able to find the value of x by setting them equal to each other. So if you want to take a second, solve for those, go for it. I'm going to keep moving on. Okay, now the equidistant chords theorem. So in the same circle, so this is only if we're dealing with one circle, so in the same circle, or so actually it can be in two congruent circles. So in the same circle or in two congruent circles. Two chords are congruent if and only if they are equidistant from the center. Okay, so in the same circle or in two congruent circles, two chords are congruent. So this will be congruent with this chord if they are the same distance from the center. So like if we take this right here and we go and draw the distance from here to here, if we draw similarly the distance from here to here, so if we find that this, so if these are equidistant, so the same distance away from the center, then the chords A, B, and C, D would have to be congruent. So these are congruent if and only if these are congruent right there. So that's pretty much all it says. So in this example here, here's our diagram. So in the diagram, it says that QR is equal to ST. So we know that they are congruent and they're equal to 16. It says that CV is equal to 5x minus 9. And here it says that this is equal to 2x. And it wants us to find the radius of this circle. It wants us to find the radius. Okay, so this is actually quite a bit to unpack. Okay, so first of all, let's focus on the information given. So I know that this length right here is 16. This length right here is also 16. Okay, now that's not really too concerning as of yet. But what we do know is that it is actually it does actually tell us that we can use this theorem. So it says that if this right here is the same distance as this chord right here, that means that they have to be the same distance away from the center. So that means that CU has to be the same distance as CV. And we're given that these two segments are 2x and 5x minus 9. So I can actually set these equal to each other. Again, because we know that this chord and this chord are the same, they're congruent, so that means they are equidistant from the center. So knowing that, let me subtract 2x from both sides. So this would be 0 is equal to 3x minus 9 plus 9 plus 9. So I get 9 is equal to 3x. Divide by 3, divide by 3. And I should get that x is equal to 3. So x is equal to 3. Okay? X is equal to 3. So pretty much right here, if x is equal to 3, that means this distance right here, I know that CU has to be equal to 6. Okay, so that's important. It's not what we're trying to find, but we do know that that is what it is. Now, also take note of the fact that this right here is perpendicular. Excuse me. Now, because it's perpendicular from the congruent corresponding chords theorem, not that one, the perpendicular chord bisector theorem, that because it is perpendicular, then that means that that this chord is bisected, meaning that it's cut into two equal halves. And it's given to us that this length right here is 16. So that must mean that this side length has to be 8 and this has to be 8 as well. Now, because we know that, and we know that this is equal to 6 right here, remember that our objective is to find the radius of the circle. The radius of the circle is a point from the center of the circle to any point along the circle. So if I choose my point to be right there, notice that we just created a triangle, a right triangle, because of this angle right here. And we know that this side length is 6 and this side length is 8, so we just need here the hypotenuse. This is the radius, right? So if we know that, then we can use the Pythagorean theorem, so 8 squared plus 6 squared, and that will equal r squared. And I'm trying to solve for r, which will be the radius. Now, 8 squared is 64, and 6 squared is 36. Added together is 100, and then I can take the square root, and the square root of 100 is 10, so I know the radius would have to be 10. And there you go. That's it right there. So there's a lot of information that you have to really soak in on this one. So make sure that you're careful and that you read, reread, and really find out what's congruent and what you can do with your information. Okay, so knowing that, in these examples, I want you to go through these ones. It wants you to find the radius of the circle, so it's basically the same thing. Now, notice that here it says that BP and BPE are 3. Both of them are 3, which means that this right here, which means that these chords are congruent. So DF and AC are congruent, so you could find the value of them by setting these equal to each other and solve for x. Now they're also perpendicular, which means they're bisected, so you can find the length of these ones right here, and you can make a right triangle from those right there. Okay, so you should be able to do that with most of these right here. This one is just the other way around, so these ones we know are congruent, which means that these have to be congruent. Okay, so I think you should be able to do it. Follow the example that I set forth here, and it should make sense. Okay, if not, just make sure you send me an email, come talk to me, and ask for some help. But that should cover everything from 10.3.